students.
Yeah, that's fine.
I have to record this.
Yes, yeah, that's fine. I can actually email you the.
Okay. Or you can get it here or put it on a USB or whatever.
I don't have a drive with me, but I can should be able to. Let's see. Can I possibly share this with you? Do you have a Gmail account that I can share with? To open
It's
it?
just my first name dot last name at gmail.com. Rodrigo.sardinas@gmail.com.
Rodrigo.sardinas. Oh, that would. Yeah. It's a slide on Google, so I don't know that it would work well. Thank you so much, though.
All
And
right.
thank you very much for letting me
Mhm.
do this.
So I need to go to Google.
Yes, please.
I don't want to go to Gmail. Is there any other way I can
Google
log into Google?
Drive. Yeah. Yes, Drive there. Should. Hopefully it'll be in. Share somewhere.
I wonder if I have to accept it first. I don't really want to open my email up in front of me.
Gotcha. Yeah, that's fine.
I can stop the screen share real quick and do this.
You know, like, okay, that might help. I'm sorry, it's not. Sorry, I didn't think of this earlier. Okay, that did work good.
Yes, can do that.
Thank you so much.
All right, sorry for the delay, everyone. We have a guest speaker here today, and they are going to share a little bit with you about an event that's going to be taking place this weekend, right?
It is, yes. Hey, everybody. So my name is Benjamin Fisk, and I am representing Auburn Hacks. We are putting on a hackathon this weekend in Brown Copel. It's starting at 11 on Saturday and going till 4 on Sunday. And so if you don't know what a hackathon is, it is just, well, you can read this. It's a 24-hour coding event. We're going to have, you come with an idea or without an idea, and we have workshops set up to you can come with or without a team or idea, join teams with ideas, or have a team formed around you if you have an idea to bring. If you don't have an idea, you can come, and the workshops we have there will give you help thinking of stuff to do, and also they'll help you develop the skills you need to implement your idea. We're going to have cash prizes and other prizes there for the winners of the competition. We also have free food and free merch, t-shirts and stickers and stuff for the event. And there's also going to be, we're sponsored by some big companies, Lockheed Martin, for example, sponsoring us, and they're going to be sending out recruiters for, looking for people to do internships and stuff. I know people who've gotten internships just straight out of this event. They didn't have to go through an internship process or anything. That may not be the case always, but it's happened. So yeah, that's what's happening. Any questions? Yes.
Do they have any beginner friendly
Yeah,
content there?
they do. They have those corporations that have sponsored us. They send employees, speakers to do specific workshops that will train beginners there in certain areas. And the people who are leading the teams are often more experienced, and you can, if you're inexperienced and want to join a team, then you can come and join one of the teams, and you'll get experience and knowledge doing that. Anybody else? Yes. How do you what? We're having judges there, and so the way it works, you design your project for the first 24 hours or so, then you submit your design idea through a website, and then in the last 2 or 3 hours, or 2 or so hours, I guess, you bring your project into the grand hall, and the judges walk around and look at all the participants' projects, and they'll consult, and then there'll be a few winners based on, I believe there are going to be different, couple small categories, and then an overall winner.
They've had a winner in the beginner category too. That was why I mentioned
Mm.
that earlier. So there is a beginner prize. If this is your first time, I think someone made an iPhone app or something. So you just go have fun. It is a fun little 2 days. Most people sleep here. If they stay here and they just work for 2 days straight. Um,
It's the whole upper floor. You've got the study rooms in the top floor of Brown Copel. So teams can kind of pick a study room and sit down and work the whole time. So yeah, it's pretty cool, pretty interesting. Hope you guys are interested, and I hope to see some of you guys out there. Here's a QR code, and you just go to that website there. You can type that in to your browser if you want to sign up. Thank you, guys.
all right, thank you.
Okay,
Thank you very much.
thank you.
Good day. All right, where are we? We are right here in branches. So we're going to start talking about selection today. It is kind of fun though. Y'all should go if you don't have anything else to do. It's like a marathon, I guess. Some people don't sleep. Some people stay up for 2 or 3 days straight working on those projects, but they do some neat stuff. I think I saw one group once, an engineering related one. They programmed what do you call those helicopter things? Quadcopter. Yeah, there's another, those kind of things. What is it? Drone, yes. They programmed a drone to monitor people in the swimming area for things that they would detect as drowning, and then the drone would bring drop a life jacket out there. So they actually ran real simulations and all kind of stuff. It's really neat, some of the stuff people do. So even if you're not doing it, some of the stuff people do is really cool out there. So you might, and again, they do engineering type of stuff. There's mechanical stuff there's electrical engineering stuff. It's not just programming. You do have a program, but there's other stuff there that you all might be interested in as well. And with that, that's not fun. This is fun, right? Let's get back to the fun stuff. Exciting. We are going to talk about selection statements. So we'll start with a picture. This is the idea behind how a selection statement behaves. If you think about this dot as the execution of statements in your program. Recall we mentioned that statements are executed linearly, right? Execute instruction number 1, instruction number 2, instruction number 3. So you can think about that like a straight line, and that being the flow of control for your program. Then you get to a certain point where maybe you want to make a decision, and maybe I either want to execute set A of instructions, this collection of instructions, or maybe I want to do this set of instruction, but it's not linear anymore. I'm either going to do this one or that one based on some condition, whether or not that turns out to be true or false. And then we'll go back to our same linear path again. So that's the idea behind how selection statements work. Here's our simple definition. A selection statement allows you to choose between one or more outcomes based on the value of some condition. And we'll look at a couple of types of selection statement, but here's another example. This is a kind of a pseudocode example. So pseudocode just means it's not actually code. It kind of looks like computer code, but it's not code, right? So it's a mix of English and computer code. That's what this is. So the example here is, let's suppose you want to buy a soda, and maybe soda costs $2. It might even cost more than that now. But let's say soda costs $2. And the idea here is if you have enough money, you're going to buy the soda and drink it. Otherwise, you drink water. So what would the code look like? It might look something like this. You've got a variable that has the price for the soda. You have another variable that represents how much money you have. And then we're going to go into this selection statement. If the amount of money I have is greater than or equal to the price of a soda, what am I going to do? I'll buy a soda and drink the soda. Otherwise, here's what I'll do. So we specify two different sets of instructions. This is our condition, right? This is the condition that's going to determine which of these sets of instructions we're going to execute. And then we'll either do this one or that one. So there are in C, there are two types of selection statements. I know there are more than two bullets on this slide, but there are two types of selection statements in C. You have if statements and you have switch statements. Now the if statements, notice we have three bullets that all start with the word if. The if statements, there are variations of how you can write this one. This one always looks the same at the bottom, but this one you can write it differently and it does different things. That's why we have this slide here. And all we mean by this one way, two way, n way is these are how many sets of instructions you have to choose from. So with a regular if statement, you got one set of instructions and you either do them or you don't. You either do it or you skip them. There is no other set. It's do it or don't. With if else statements, two way, you have two sets. This is more like this example here, right? I'm either going to do this or I'm going to do this. I won't do them both, but I will do one of them. And then of course, the last variation where you can have multiple sections, if you would. I'm either going to do section 1 or section 2 or section 3 or section 4. I'll do one of them, not all of them, but I'll potentially do one of them. And the switch is kind of like the last one, the switch statement. So let's look at a simple example. This is a real if statement. We have a variable here. This has the temperature. This is an integer, a whole number. Temperature is 50. And what we want to do is just if it's hot, if it's, and we represent that by saying that the temperature is over 83. If it's more than 83 degrees, we're just going to say it's hot. So we start with the word if, right? So to write an if statement, you always start with the keyword if, followed by your Boolean expression in parentheses. So the parentheses are required. You have to have the parentheses in C. 1 minute, let me get this out so we can kind of demonstrate as we go. Okay. One minute for the, there we go. So we'll just use this for now. And we'll have our main. And here we'll have int temperature equals 50. And here, if we need the parentheses, they are required, followed by some Boolean expression. Now remember, C, there's no such thing as a Boolean data type in C. That's really what we need, is a Boolean value. So in C, like that's true, right? Anything that's not the number 0, that's false. Anything else you put in this parentheses is true. In this case, we'll write an expression. This is a more realistic example of how we would use it. And then below here is what I want to do if that is true. So is hot. We'll just do this. So we can see if I compile this and run it. Let's get rid of some of this. Compile it and run it, and we can see. Huh, what happened here? Why are you not printing? T is greater than, oh, whoops. Well, it's not, well, good, let's use this. If it's greater than 83, we're gonna print if it's hot. So notice I'm gonna keep running this and it's not printing anything on the screen, right? And that's because this condition is false. So it's completely skipping this instruction. If we change this to something that would be true, let's say, what if it's less than 83? It's not necessarily hot if it's less than 83, but just so that we can see how it would behave. If we run it now, we can see that sure enough, it actually does execute that instruction on line 8, right? Because this is true now. So if this is true, I'm going to execute the very next instruction that I see. So here's what we do if that's true. Now, in the example we just gave, we only had the ability to execute one instruction. Now, this is important. This is pretty important. And the way the if statement, and we'll cover other statements that are similar, the way if statements work is immediately after the if statement, the very next instruction I see is the instruction that belongs to the if statement. So that's obvious here. This is my next instruction. But here's something that's not so obvious. Let's change this to greater than. We're going to run it, and we can see that, well, let's clear it. We can see that T is not greater than, the temperature is not greater than 83. It doesn't print. That's what it should do. But what if we do this? And this is something that I see the students do a lot, because we sometimes associate, we did say that semicolons are how you demark the end of an instruction, but unfortunately, this is not an entire instruction, right? This is part of an instruction. So we'll have some students do this, and then we run it, and now look at what happens. Now it doesn't matter what this is. It should not be printing that statement. But because I put that semicolon there, what C did was C said, okay, here is your if statement. The very next instruction I see belongs to the if statement. And what do semicolons mean in C? In C, a semicolon is the end of an instruction. So I just took this instruction, that's nothing, and that's part of the if statement. This doesn't belong to anything anymore. And you can see how these lines changed when I did that, right? If we remove this and recompile it, look how these lines change the control state sequence diagram. We put that back and compile it again. You can see how it changes to show that that instruction is not part of the if statement anymore, right? So what if you do want to include multiple instructions with the if statement, right? So right now, as it is, this is the only instruction that's part of the if statement. Let's say instruction 2. What if we wanted to have 2 instructions associated with the if statement? Right now, they're not, right? And we can see that by the line here. This one is part of the if statement, that one's not. Well, you can do multi-line instructions in C by including the brackets. So kind of like you do with functions. So if I want both of these instructions to be part of my if statement, I can make an opening and closing bracket, and I put the instructions in between the bracket. And notice how both of these now, you can look at the control sequence diagram and see they're both part of the if statement. Now, if I run it, as they should, neither one of these get executed. If I change this, compile it and run it, now both of them get executed. So I have a collection of instructions now that either do or don't get executed, depending on whether or not this condition is true or false, right? So if you have multiple instructions, you can just use brackets. Now, what if we want to use the brackets with only one instruction? Can you do that? Yes, you can. And it's not wrong to do that. So you could, if you wanted to, just use the bracket for one instruction. It's completely fine. So just to be safe, if you don't remember this rule, if you feel like you're not going to remember this rule, use brackets all the time. So you're never wrong if you use brackets all the time. If you don't use the brackets, you're sometimes wrong if you don't remember how the if statements work, right? So if statement, no brackets, one instruction. If you want multiple instructions, you have to use the bracket. But it's never wrong to include the bracket, even for just one instruction. So just keep that in mind. And we kind of demonstrated this already, right? What happens when I put the semicolon there? I just overrode, even though I have these, none of these should get executed. Right, if I compile it and run it, nothing happens. But if I put a semicolon here, what do we think is going to happen? What's going to happen now with my semicolon right there? It's going to print both of those statements. That's right. That's right. Even though this is false, this is the instruction that belongs to my if statement. This is just a pair of brackets around some instructions. Right, very good. What if we wanted to have multiple sections, right? So we can consider this, we can look at this as one, as if we're just one section. Here I have an if statement. If this is true, I will execute this set of instructions. Otherwise, I'll just completely ignore it as if it weren't even there. That's how this behaves. It's a single if statement. But sometimes you want to do one or the other thing. I definitely want to do something. I either want to do this thing or I want to do that other thing. I don't want to just completely skip this section here. Well, we can use an else for that. So the else is kind of like a default statement for your if statement. So if this is true, here's what I want you to do. But if it's not true, always at least do this. And that's what we see right here on the left. Keyword if, our condition, here's what I do if it's true, followed by the word else. Now notice, and of course, the same thing applies with the brackets, right? But notice there's no condition following the else. I see this a lot. Some students will do this a lot. We don't need a condition with the else because we're not testing anything. There's nothing to test here. If you see that word, and if you ever get to that part of the instructions, it will execute those instructions, period. That's what the purpose is. This is your default selection. If nothing else gets chosen, this is what I'm going to choose. Let's take a look at that here in JGrasp. We'll use the one off first. If, and we'll just do one. We know that's true, right? Printf. We'll do section 1. We'll type that so it's kind of obvious what we're doing. Else. So remember, I don't need the brackets here because I'm only associating one instruction with this and one with this piece right here. So it's fine to do that. Let's compile this. And we already know that one is true. So it's going to do this statement right here. It's going to execute that statement that says section 1. If we make this false, I know this is going to get skipped now, right? Because that's how this behaves. If this condition is true, then I'll do that instruction. So I know it's going to skip it. And notice here, I do not have any condition. I don't care if that doesn't happen. If I ever get to line 9, I'm just going to I'm going to compile it first. If I ever get to line 9, I'll just automatically execute the instructions in here, right? And we could include the brackets. Remember, it's okay, even with one instruction, it's okay to include brackets, but they also allow us to include multiple instructions. So if some condition is true, right, if t equals 50, it does, we'll print section 1. Otherwise, we'll print section 2. So multiple instructions. And here I'm either going to do this, I'm either going to do these 2 instructions, or I'll do those 2 instructions. But notice I do not have a condition here. It's just the word else. This is your default set of instructions. If you ever get to this if statement and nothing was true, this was false, I'm always going to execute the stuff in this else block. Okay. Do you have any questions before we continue? All right, now we're going to look at the last variation of an if statement, one that has multiple sections, potentially more than 2, right? So this isn't required. This is the only thing that's required for an if statement. An if statement at least has to look like that. But remember, we said there's other stuff you can do. I can have multiple sections here where only one of these sections gets executed. So the way you would do that, let's take this example here. If I wanted to write multiple if statements, but I wanted to guarantee that only one of those things happened, we could do that as well. We would just write the word if after this. So else if. Now note, if I have the word if, I need to write another condition, right? So this is not the same as the else. It's not a default. This can get skipped. Let's just do false for now, just so you can see. So here I have the word if, and then I have an else if section. So both of these are optional sections, right? None of these are guaranteed to get executed. If this is false, I'm not going to do that. And if this is false, I'm also not going to do that. That's what this says. So let's go ahead and run it. And sure enough, nothing happens. Likewise, let's go ahead and make this true. I'm going to make both of these true. Likewise, if I enter into this section here, if that is true, I'm going to execute these instructions, and then I'm going to exit. So I won't do both of these sections. I'll only do one section. As soon as I encounter an if statement that's true, I'm going to execute the instructions in that section, and then I'll get out of this entire block, right? So this whole thing is one block right here. Now let's go ahead and make this false. That one's not true. And you can see, sure enough, this is not true. All we'll do when you write if statements like this, and you can write as many of these as you want. Else if, else if, else if. You can have as many of these as you want, and the computer is going to behave the same way. It's going to look at this if statement. If that's true, it's going to execute these instructions and get out. If it's not true, it's going to look at the next one. If that's true, it's going to execute these instructions and get out. If it's not true, it's going to look at the next one and the next one and the next one. And it'll keep doing that until it finds something that's true, or until it reaches the end of the if block. So here, if this is the way we wrote it, we would get to the end and there would be nothing to do because we don't have this one. There is no default. So if every one of these is false, we just don't do anything. All right, so here's Another example from the PowerPoint. All right, so here we're just going to use the speed, and you can either be driving too fast or too slow, or okay. So here, if the speed is greater than 50, we're just going to print your speeding. If this is not true, we're going to fall to our second check, right? What is the second check? Well, what if you're driving less than 30? Then you can say, oh, well, you're driving too slow. But if you're not over 50 and if you're between 30 and 50, you're okay. So if neither one of these things is true, what are we going to do? Well, we're just going to print that you're going the speed limit. And I don't have to check for those other things. Because of the way I wrote it, if you're not going over 50 and you're not going under 30, where are you? You're somewhere in the middle. I know that already, so I don't need to check for that. I'll just write this as my default statement, and that's what we'll do if neither one of those above are true. Oops. As I mentioned earlier, any Boolean expression can go in between those parentheses, and it doesn't even have to be Boolean, right? Remember, there's no such thing as a Boolean data type in C. So you can do something like this. I can write a string, right? That is not true or false, but it's also not the number 0. So that would be interpreted as, what happened? Oh, it doesn't like this stuff. Right, and C, what did I do? There we go. So in C, anything that's not the number 0 is interpreted as true, but any Boolean expression can go there, be it logical or relational. We can do this. We already know that's going to be interpreted as true. And what does the exclamation point do? That operator reverses whatever that value is, right? So if that's interpreted as true, this should make it false, which should get us to do the second one. Sure enough, that's exactly what it does. It negates the Boolean value in front of it. So here are examples. And this, of course, only works if you include the standard Boolean library, right? Remember, we talked about that way a couple of PowerPoints ago. I think the first or second PowerPoint, we talked about using Boolean values. But if you did, you could use the word true or 1 or hello. Anything would be interpreted as anything that's not the number 0. Single values is interpreted as true. And then, of course, you have these other examples of Boolean expression. So here's a compound expression. We're going to use or, and remember how or works. As long as one of the operators on the left or right hand operands is true, it's going to return a true. Here's another compound expression. It's actually 3 separate Boolean expressions, and we're going to put 1 less than 10. That's going to return true or false. 15 greater than 10, true or false. And then we'll combine those 2 values using the AND operator. And here are examples of a bunch of Boolean expressions that would return false. All right, any questions over if statements? Any questions over if statements? All right, we have about 15 minutes left. So let's stop here. And what I'd like to do, if you go to Canvas, those of you that have your laptops with you, if you go to Canvas, you should see this. It says if statement exercises. I would like you to go here and pick one of them to work on. I don't care which one, pick one and write that program. Let's take, for example, let's take this one. So what would this do? This program would find the maximum between 2 numbers. So if I give you 2 numbers, you could use scanf to save 2 numbers, then use an if-else statement to print the biggest one, right? That's all this does. So you pick which one you want to use. Here it is in Canvas. Let's try to do one of those exercises. I don't care which one you do. And I'll be here to answer your questions if you have any. Here are all the different, some of the different things you can choose from right here. And the nice thing about this, they do show you the answers here. I would encourage you not to look though. Again, this is not for a grade, but they will show you the answers here. So this is a nice place to go if you want to get some practice. If you get stuck, you can always just look at the answer and see how they did it and keep going. Mhm. Just in case someone has a question about the exercise. Mm-hmm. My best guess. Just curious, we only have a few minutes left. Was anyone able to complete any of the exercises? Okay, all right. You all are free to go when you're done, by the way. That's all we had for today. I just wanted to sit here in case you had questions or you got stuck. Try to help us get through this exercise. It's open projects. It's in the brown, let me see, browse. Open projects in mine is what it's called. How can I help you?